Hey everybody, this is a quick video on factorial ANOVAs. It's chapter 12 in Field's book, and the data we're going to be using today is goggles data. So, a quick run over for a factorial ANOVA. You're trying to predict a number based off of multiple categories. So our number would be kind of our dependent variable, and the categories and their interactions as our independent variable or factors. So I'm going to load in goggles data, which is a CSV file. Alright, having pulled that in, it's not labeled correctly, so I'm just going to relabel it to none, 2, and 4. You can take that, my word for that, or you can not do it, and your things won't be in a good order. I'm going to pull in past x, and I'm going to do only one very brief descriptive statistic command. Okay, so for my females, at no alcohol, we have an average of 60. That's the attractiveness of the person they go home with. Then 62, then 57. For males, we have an attractiveness of 66, then 66, and then 35. So a pretty big drop there. Without stats, we can guess that those two are statistically different. Now, to run our assumptions, first we need library car to run a Levine's test. And we're going to run a Levine's test not on each variable, but instead on the interaction of variables, because this is interested in the interaction between our factors. And that does not violate the assumption, so we'll move along. Had we run it on alcohol and gender separately, one of them does violate the assumption, but that doesn't bother us now. I'm going to create a simple model before we get any further along and run analysis on it. So this simple model says we're trying to predict attractiveness based off of gender, alcohol, and the interaction between gender and alcohol using goggles data. Given this, we would say that the only significant scenario right now is the interaction between gender and alcohol, but we want to know a little bit more than that. So, because of that, we can run a post hoc test. Here's a post hoc test, and that gives us the difference between none and 4 points, which appears as significance, and the difference between 4 points and 6 points, which appears significant, but doesn't let us know anything about genders. And recall, we were interested in the interaction, so neither of those really satisfy what we're looking to find out with this test. So now I'm going to build some contrasts. I like building my contrasts ahead of time with names that I can read and understand, and then binding those contrasts to the variables I'm going to be using. So I created the none versus some. The -2 is the placebo, which was no alcohol. The 1 here is 2 pints, the 1 here is 4 pints, so it's no alcohol versus alcohol. Next I have low versus high in the alcohol, so 0 is none, -1 is 2 pints, 1 is 4 pints. And then female versus male should be pretty straightforward. Alright, so now that I have those, I'm going to create another model this time, and I'm naming this CM for a contrast model. Oops. Shouldn't matter that that happened, hopefully. Pasted the wrong thing. I hate it when that happens. We'll see if that messed things up. It did not. Excellent. So now I can kind of read and see what these things are. So our female male, no significance. Okay. Alcohol none versus some, significant at a pretty high level. Alcohol low versus high, significant at a pretty high level. For female versus male, so this gender difference, there was an interaction between that value and the none versus some at a significant level. And there was an interaction between the gender value and the low versus high at a significant level. Okie dokie. So let us move along. Had we wished to, we could questionably interpret these R-squares. I'm not going to talk about those at all right now. Alright, now moving along, if we had violated an assumption in there and we wanted to run a robust method, our option is this MCP using the WRS2 library. So that follows the form of number by your groups, same as we had before. Really it just replaces AOV with the MCP2A, and we're going to run that. So this inboot says run it 200 times, use our data, and you will be able to compare this to the values that are found in chapter 12. They won't be exactly the same because this is bootstrapped. Bootstrap means that we're taking a random sample over and over again, but they should be approximately the same, which is to say the ones that are significant should be significant over there, and the ones that aren't significant should not be significant. It would be very surprising if those were different. Alright, that's the end of this particular video. Cheers.